When completed, as depicted by this operational prototype, a launcher facility permits a missile to be serviced and fueled within its silo, then raised to the surface for firing. From the opening of the silo's concrete doors to the moment of launching, a missile is exposed for only a few minutes. Both Titan and Atlas missiles will use this type of launcher. A more advanced silo launcher system will permit Titan to fire directly from the hole. The first flight test of a Titan missile fired from the bottom of a 146-foot deep silo took place in May 1961, a major milestone in ICBM development. Minuteman, the Air Force's new, comparatively low-cost solid propellant ICBM, has also demonstrated the feasibility of the fire from the hole concept. In 1959 and 1960, a series of test firings with tethered missiles completely proved out the system. All of these missile launcher systems are currently under construction, but the task is staggering in scope and complexity. The rate of construction must be accelerated until we are completing 2 launcher silos a day in the later stages of Minuteman site activation. The job is big and complicated. The structure alone for one soft emplacement contains 129,000 tons of steel and concrete, nails and lumber. A control center has nearly 4,000 miles of electrical circuitry. Building the complexes is a new exacting science. It requires construction tradesmen to work to tolerances found in aircraft plants. Men who mastered their crafts on bridges and buildings must now build structures rugged enough to survive nuclear blasts, complex enough to service and launch giant missiles. But they must build these structures with the precision demanded of machinists. They must install miles of electrical wiring with the knowledge that one faulty circuit will knock a missile out of action as effectively as a bomb. They must assemble fuel storage tanks and loading lines with a hospital's concern for cleanliness, knowing that a speck of dirt can cause a damaging explosion if it comes in contact with liquid oxygen. And constantly emphasized in each of the thousands of construction and installation steps is the necessity for planning, coordination, and teamwork. A launcher must be delivered and installed on schedule so that it will be ready to receive the next section of equipment when it arrives. The part manufactured in Phoenix, Arizona, must align perfectly in the field near Salina, Kansas, with another part produced in San Diego, California. Any change in the design of one part must be incorporated in the design of its counterpart before the two meet at the missile site.